Hello guys, welcome to my new series, A Question a Day, where I'll be going through one GCSE Sciences or Maths question every single day. So, let's get started. A satellite is in a circular orbit around the Earth, and figure 14 shows the velocity of the satellite at two different positions in the orbit. We need to explain why the velocity of the satellite changes as it orbits around the Earth. So, the first thing that I would say is that the satellite is constantly accelerating towards the center of the Earth. Now, you might be thinking, how is the satellite accelerating if it's traveling at a constant speed in orbit, right? However, velocity changing doesn't just have to mean the speed changing, it could also mean the direction, okay? So forces can not only change the speed of something, but they can also change the direction of its motion. What we're seeing is the gravitational force is what's causing that constant change in direction that's happening during orbit, and that also directly means a change in velocity. And finally, to tie things together, I would say that that change in direction means that that velocity must also be changing, since velocity is a vector quantity that depends on both the speed and the direction of that speed. Okay, moving on to the next question. Figure 15 shows how the length of a satellite orbit depends on the height of the satellite above the Earth's surface. Now, we can see the length of the orbit in kilometers on the y-axis and the height above the Earth's surface in kilometers over here. So the question asks us, a satellite orbits 300 kilometers above the Earth's surface at a speed of 7.73 kilometers per second. We need to calculate how many complete orbits of the Earth the satellite will make in 24 hours. So the first thing that we should do in this question is take a look at the mark that they've given us for 300 kilometers above the Earth's surface on the graph that they've given us, which is over here. Let's just draw a line directly up from 300. Okay, so now having drawn this line, we can see that this is 1,000 broken up into 10 increments, and so this should be over here 42,100 kilometers in length. So 42,100. Let's write that down. Okay, now that we have the length of this orbit, we now need to calculate how far the satellite's going to travel going at this speed, 7.73 kilometers per second, in a full 24 hours so that we can divide that figure by this figure, which is the length of one orbit, to get the number that we need. So let's do that. Quick reminder why we're doing this. Speed is equal to distance over time. So in order to get the distance traveled, we need to do the speed times by the time. Now the speed is in kilometers per second. Time was in hours, so we needed to convert to seconds first. So now that we have this figure over here, this 667,872 kilometers total traveled, we can divide this by 42,100 in order to get our answer. So the figure that we get is 15.86, but since the question asked us for how many complete orbits of the Earth the satellite made in 24 hours, it would be 15 complete orbits. Okay, now moving on to the next part of the question. In 1772, an astronomer called J. Bode developed an equation to predict the orbital radii of the planets around the Sun. Table 3 shows Bode's predictions for the orbital radii and the actual orbital radii for the planets that were known in 1772. So we can see all the planets, Mercury through Saturn over here, and their predicted orbital radii and their actual orbital radii. So the reason that this data would be considered accurate is because if you take a look at each of these figures, they don't seem to be more than 10% off in any case. So what you'd say is that the data that he predicted was very close to the true or the actual values of the orbital radii. Finally, for the last part of this question, J. Bode used his equation to predict the existence of a planet with an orbital radius of 2,940 million kilometers. The planet Uranus was discovered in 1781. Uranus has an orbital radius of 2,875 million kilometers, and we've been asked to explain why the discovery of Uranus was important. Now, in this case, what's important here is that J. Bode used his equation to predict the existence of a planet that they didn't know at that time, which was obviously later discovered to be Uranus, right? So what this question is asking us is if we understand how science works. So science works by people creating models, by creating predictions, and then experimentally either verifying or falsifying those predictions. So you create a model, you create an equation of some kind that's used to make predictions of the real world, and then you go out, you do observations, and if those predictions are close, then it would verify or provide evidence for your theory that you came up with. Or if those predictions were not close and the real life results were nowhere close to what you predicted, then it would falsify your theory. So in this case, we would simply write down that if you made it this far in this video, thank you so much for watching. Please like and subscribe, it helps out a lot. And if you want to see some type of content covered that you're revising right now that you're struggling with, then leave that in the comments and I'll try and cover it in the next video. See you guys next time.